Hi everyone, Mrs. Woodruff here today. We're going to take our discussion of volumes of cylinders a little bit further today with just a few extra problems. But before we do that, let's take a minute to just remember what we talked about yesterday. So I'm going to ask you to pause the video, and if you could right now, calculate the volume of the two cylinders, please, on the screen. And when you're set, come on back and we'll see how you did. Okay, everybody, so we take a look at this top cylinder, and I notice that it has a diameter of 12 centimeters, but the volume formula for a cylinder requires the radius. So the first thing I needed to do was cut that 12 in half to get the radius. So you're going to notice a 6 show up in the formula here. Remember that the volume of a cylinder is the radius squared times the height times pi. And we're going to start by doing this math. So our first step is to take the 6 squared times 3 in our calculator and hit equals. Should have gotten 108, and we're going to leave the pi, and we're going to leave that step in our work to show what's called our exact answer. We have not rounded and we have not approximated pi. Now we're going to take our calculator, 108 times the pi button, 3.14 if you can't find it. And your answer should be about 339.3 centimeters cubed. Now remember, if you use 3.14, your answer could be slightly smaller. Also, one place, when we're rounding to the 10th, that means one decimal place. So I looked one number past that first place and checked to make sure I was rounding correctly. Last thing, did you remember to put your units, and did you put that cube on there to show everybody that it's volume? Remember that a single unit, not having an exponent other than 1, would be distance. A squared would be area, and a cubed, a third, would be volume. Now speaking of volume, let's take a look at this red one. This time they gave us the radius, so we're ready to go. The volume is the radius squared times the height times pi. I'm going to take 2.1 times itself, or raised to the second power, times 3.5. And in the calculator, I see 15.435. Notice I did not round yet. I'm going to round my answer at the end, but right now I'm leaving all of those places, and I'm going to multiply by pi. And you should have gotten about 48.5 meters cubed for the volume of the red cylinder. We have our exact answer and we have our approximate answer. So that's kind of where we left off yesterday. So today we're just going to add one idea, and the idea is of composite solids. We did some of these last year with prisms and pyramids. This year we're going to start to see our round, our circular volumes come into the composite problems. Now, a composite just means that it's more than one shape. And sometimes you're going to have to add the volumes, and sometimes you're going to have to subtract. So if it's a hole or something being hollowed out, we're going to take away volume. And if it's sort of a stack with things on top of each other, we're going to add volume. So here's the first problem. You can see that it is a cubed shaped bead, and it has a cylinder drilled through it. So there's a hole here that's in the shape of a cylinder, and we want to find the volume of the bead. So basically we need to find two volumes. We need to find the volume of the cube, which is going to be 12 by 12, and since it's a cube, its height would also be 12. And that's what you see happening right down here. 12 times 12 times 12 is 1,728, and that's the volume of the rectangular prism, in this case the special rectangular prism, the cube. Now we're going to go back, we're going to just pay attention to the hole, which is in the shape of a cylinder. You're going to notice they gave us the diameter, so again we have to cut that in half to get the radius right there, so 1 squared. We're going to take 1 squared times the height of the cylinder, which is the side of the cube, which remember that height was 12. So we're going to take 1 times 12, so 12 pi would be the exact answer, and then when we multiply it, we get about 37.7 cubic millimeters. To find the volume of the bead, we have to take away the cylinder. Remember, it was drilled out, so we're going to take the volume of the cube minus the hole, minus the cylinder, and the bead would be 1,690.3 millimeters cubed, or cubic millimeters. So this one kind of reminds me of a mailbox in a way. And if you'll notice, we've got two shapes. The bottom shape, again, is a rectangular prism. It's not a cube this time. It's 30 centimeters high, 25 centimeters wide, and 50 centimeters long. So we're going to have to find the volume of that. Now on the top of it is a cylinder cut in half. So it's half of a cylinder. Right here would be its radius of the circle. If that circle kind of came all the way around, you can see this would be the radius. And we're going to have to use this number down here, which goes all the way across, to come up here and figure out what the radius is. And then the cylinder is laying down, kind of like it's sleeping. So the height of the cylinder is actually running along here. It kind of fell over. So you can see that its height would be this 50 centimeters. That this would also be 50 centimeters. So we're going to have to break down the shape. We already talked about there's going to be half of a cylinder sitting on top of a rectangular prism. I like to start with the easier part, so I'm going to find the volume of the box of the rectangular prism, which is length times width times height, and that will equal 37,500 cubic centimeters. So we're going to kind of put that to the side, and we're going to come up here. We're going to look at our cylinder. Remember, we need this right here, this radius, which would be half of the 25. So if this is 25, this is 25, and if we take half of that, that would give us our radius. And don't forget, I mentioned that the height is actually right here. It's laying down, which would be the 50 centimeters. So our volume, we're going to take our volume formula for a cylinder. Our radius is going to be half of the 25, which is 25 divided by 2, 12.5. We're going to square that. And the height of the cylinder, keep your eye on the cylinder right here, is 50. So we're going to start with this formula. We're going to take the radius squared times the height. And it would be 7,812.5 pi would be our exact answer. And if I multiplied it, it's about 24,543.7 if the cylinder had been whole, but we chopped half of it off. So we have to divide this by 2. In the calculator, it's really easy to multiply by 0.5. Dividing by 2 is the same operation as multiplying by 0.5. And that half of a cylinder, kind of like a soup can cut in half, would be 12,271.8 centimeters cubed. Here's the half cylinder. Here's the rectangular prism. Notice they're stacked on each other, so we're going to add those two volumes, and the volume of this composite shape that looks like a mailbox would be 49,771.8 centimeters cubed. Don't forget, you can pause the video if you want to kind of look at this, write this down, see what's going on. Feel free to do that. Let's do another example together. Last one for today. So when I look at this shape, I have to kind of break it apart, and I notice there's sort of like a box on the bottom and a box on the top. Those are rectangular prisms, and if you look at the dimensions, they're identical. Their height is 5, their width is 20, and their length is 8. So if we take 20 times 8 times 5, that would give us one box, but don't forget we're going to do 2. Let's start there. So you see where those 3 numbers came from. We multiply them out. That's 1 multiplied by 2, and we have 1,600 meters cubed for the 2 boxes. Now let's go to our cylinder. Now I got to look here, and I notice across the base circle, they've drawn a line from end to end, which means that's diameter. The diameter isn't what I need to find the volume of a cylinder. I need the radius. So I'm going to take that 8 and cut it in half. I'm going to be using 4 for the radius. I'm going to take the radius squared times the height of the cylinder. So the 4 squared times 15. It's going to give me 240. That's 16 times 15. And when I take 240 times pi, it's about 754 meters cubed. I put the 0.0 here because it rounded to that. And then here I'm going to add again because they're stacked on top of. I'm going to add this volume to this volume to this volume. So I add those two numbers, and the volume of the composite solid is 2,354 meters cubed. So that's kind of where we are today, is starting to put some of our shapes together. In this case, prisms coupled with our cylinders. So there's a few problems for you to practice on. Tomorrow, I'm hoping we can move on to a new shape. It's my favorite one because it often holds ice cream. Anyway, have a great day, guys. I'll talk to you soon.